So we've looked at stretching horizontally and vertically. We've looked at shifting vertically. It is now time to examine those horizontal shifts. Now, just so you know, when we are dealing with sines and cosines and other trig functions, those are very often referred to as phase shifts. That means the same thing as a horizontal shift, just moving your graph to the side. So setting your A and B back to 1, your C and D back to 0. What I have here in orange is the regular old cosine graph. And then in blue, as we fiddle with things, you can see the transformed graph. I hope it's not a big mystery that when it comes down to which parameter moves you sideways, the only one we haven't used yet is letter C. And sure enough, it's that C that's in the parentheses with the X that moves your graph to the left and to the right. So let's take a look. It's C that takes care of your phase shifting. Now, here is an example of two graphs that have been phase shifted. I do want you to be aware that just looking at a graph that is periodic, you don't ever really know exactly what the phase shift was. Like I can tell this graph has been moved to the side, but let's imagine it started as a cosine. Did it move from here to here? That'd be a phase shift to the right. Or did this peak that is normally at x equals 0 move to the left, a phase shift to the left? There's no way to tell just by looking. That's why on your practice, you're actually going to have the equations you're working with to make those decisions. Okay, let's now examine which type of C's move us left and which type of C's move us right. So with a little bit of experimentation, so starting from 0 for my C, if I make C positive, moving to the right, and if we make C negative, moving to the left, it really is as simple as that. So you shift left if your C is negative, and you shift right if your C is positive. Now, here's what makes that a little bit tricky. Notice that in the equation, it's x minus the C value. So if you do, for example, minus a negative, it actually looks like a plus. And if you do minus a positive, it actually looks like a minus. What I mean by that is, down here, see how there's a minus in here? That's actually a shift to the right, because you're subtracting a positive C value. Whereas this one has a plus, it's going to end up being a shift to the left because you're subtracting a negative C value. Now, what makes this complicated is that before you can determine the phase shift, you have to do an additional step of dividing out B. Here's how it looks. We're going to focus on what's in the parentheses here. I do need you to know that theta divided by 4 is the same as theta times 1/4. And in order to be able to quickly identify what the phase shift is, we need to factor out, divide out that B coefficient of 1/4. So to do that, 1/4 theta divided by 1/4 leaves you with just a theta. But for this one, you actually need to write out, take the 5 pi over 4 and divide it by whatever number was in front of the theta. So divide by 1/4. All right then, dividing by 1/4 is the same as multiplying by 4. That gets reduced away, and we are then left with just the 5 pi. So here's what I would like you to do, is rewrite what's in these parentheses this way. It's really 1/4 times theta minus 5 pi. This makes it so much easier to identify the phase shift. That's a minus, so it's a shift to the right. And I'm going to call this PS for phase shift. And how far? Well, by 5 pi. So the whole graph got shifted to the right, 5 pi units. I know that because of the minus and the 5 pi. Let's go again. I'd actually like you to do a quick pause, try this one yourself, and then unpause when you're ready to check it. Here's what I'm noticing. I got a 5 in front of the theta. So then the question is, what do I get when I take the pi over 2 and divide that by 5 as well? I do need you to know that dividing by 5 is the same thing as multiplying by 1/5. Multiply across the tops and across the bottoms, we get a pi over 10. This makes it very easy to see what the phase shift is. I see the plus, so we're moving to the left. And how far? Well, by pi over 12. I do encourage you to check that with a graph. So if you graph this, you should be able to see that you move to the side just a little bit, moving left by that pi over 12. And the more of these you do, the more confident you're going to be with them.